Hi everyone, my name is Arman and we'll be presenting our medical imaging term project, ultrasound imaging simulation for examining target points reaction to ultrasonic pressure. The contents are as follows. So the abstract of our project is ultrasound simulation is implemented in MATLAB for determining the effects of ultrasonic pressure on specific target points. K-Wave toolbox is used for these simulations. 3D model of the brain is downloaded and is used as our data set. And 3 different ways of ultrasonic wave generation is examined and discussed. So ultrasonic imaging utilizes ultrasonic sound waves for generating real-time grayscale scans of a patient's internal tissues. These ultrasounds are classified as sound waves with high frequencies that are imperceivable to humans. Uh, a transducer or a probe is used for the conversion between electrical signals and acoustic signals. This in turn allows the operator to scan a target point of interest. Acoustic waves are pressure waves that propagate through matter by compression and expansion of the matter. As the acoustic waves collide with different tissues with different propagation medium properties as they're traveling, their corresponding echoes come with relative different strengths. So the point of care ultrasound imaging or POCUS is a preferred method of scanning brain tissues of newborn infants. Ultrasound for this specific case of brain imaging is highly preferred compared to MRI scanning due to its non-invasive nature, along with it having no requirement for stability in a patient, which in turn is necessary while imaging the brain of infants. Ultrasonic sound waves cannot penetrate the skull tissue in adults. So for this purpose, our simulation ignores the skull and justifies the reason behind this in the simulations and the report. Now my friend Elif will talk about the methods and the results section.
Data obtained from the site stated contains 3D cross-sectional data of an adult-sized brain. For this project, we used a slice corresponding XY axis of the brain structure to generate 2D simulation of ultrasonic wave pressure. You can see the picture of the model that we have used from the picture. With respect to the data set and the positions that our mediums are located, properties of the mediums are identified. Target points are chosen and different sources of ultrasonic waves are formed to monitor these points. Imagining brain structures through the skull with ultrasonic waves becomes problematic due to the values of this propagation medium. For observing the effect of the skull to pressure, a simulation is conducted, including just the sources generated. For the target points, the skull is ignored to have a better examination. One can see the table of the properties of propagation mediums. The values in this table is implemented because this allows us to manage different tissues and their responses to the acoustic waves and observe the target points more realistically. One can observe the target points and sources that are used to simulate ultrasonic waves from the figures. First source indicates an array of sequential points surrounding the brain. Second source is a linear source placed outside of the brain, and the third source is a random points generated for simulating sound waves. First simulation is conducted to observe the effect of the skull to ultrasonic waves. On the left side, first source and the pressure distribution can be seen. Similar simulation is done for the remaining sources too. One can see the ultrasonic waves cannot penetrate the external hard skeletal tissue as the skull does not allow most of the ultrasonic waves to pass through. Simulation with 3 different target points is made with the sources. The outcomes of the first source suggest that the target points can be observed with the ultrasound clearly, and the specified target points could be focused. Linear source outputs pressure distribution such that there exists a linear orientation towards the target point locations. Direct focus cannot be observed through this source. However, it can be said that it seems to be successful to identify the direction of the target points and still provides a higher pressure along. The results of the third source suggest that there appears intensity of higher pressure points near the target point locations. However, the target point seems not the only focused locations due to the randomized source generated. And now Onur Khan will discuss the discussion part.
And finally, once we cover all these sources and compare them, we observed that for first and foremost, we observed that the effect on skull and simulation, the solid external skeletal structure is not permeable for the sound waves, so it blocks the sound waves and prevents observation. Therefore, it decreases the precision and resolution and increase the probability of errors. Therefore, we used in simulation, we did not include the skull. We neglected it, ignored the skull. And from these simulation results that we ignored the skull, we found that the first source, the target points are focused clearly, and we can observe that the location of target changes. Ultrasonic waves are still able to focus a specific point, even though the sound points are scattered along the brain cavity. And linear output gives high pressure distribution. If we observe the figures, we can see that the high pressure distributions are closer to the sound source. So we can say that the resolution near the sound source will be higher. But if along the direction of target points, we have still lacking precision, and randomly generated points is not that clear. The focus on target points is not that better. There appears high intensity near points, but observation is not clear. So these are the points that we have come up. Thank you for listening.
So you can see a sped up version of our simulation now.